Okay, good point. Can you hear me? Okay. Last week we discussed about frequency distributions that or ungrouped frequency distributions. Okay, I told when increase the number of data more than 25, 30, it is very difficult to analyze, very difficult to do calculations by simple method as a simple frequency distribution method. As example, if you try to get the mean x bar in simple method, you have to add all numbers sigma I equal 1 to n x I. You have to divide by number of data. You have to add all numbers and divide by number of data n. It is very tough if when it is number of data increasing more than 25 to 30, 35. It is very difficult. That's why I told we have to go to second method. What is the second method? Our first method. What's the name of our first analyzing method? Simple frequency distribution method. Simple frequency distribution. That's ungroup. The second one, ungrouped frequency distribution method. Ungrouped frequency distribution methods. Ungrouped frequency distribution method. Okay. Last week we did two calculations. Am I correct, Tanga? Last week we did two calculations. Ungrouped frequency distributions. Am I correct? Fatima? We did only two calculations. Okay. Correct, right? Send me message. We did only two, as I remember. Dihini? How many calculations we did on the ungrouped frequency distribution in our second part? Yeah, two, only two. Okay, let's move into past paper questions to find about ungrouped frequency distribution questions. Okay, let's move into 2016. 15th one completed. 15th one based on 2015 question based on simple frequency distribution. Simple frequency distribution. Let's move into 2016. Do you have any class today? Afternoon? Udanya? Only evening you have class, right? Why are you silent? Please answer. Fatima, you have class only evening. No class today. Habib, Dihini, no class today, right? No. Then no problem. Okay, we have time. Let's do question number 5, 2016 A level. Okay, standard length of a metal rod produced by a company should be 5 meter. Standard length of a metal rod produced by a company should be 5 meter. Yeah, the standard length is 5 meter. Length 5 meter, but however, the metal rod with various lengths were reported due to mechanical errors or human errors. Various length rods were recorded. Now, a random sample containing 20 rods was chosen, and the length of each rod in centimeters are given below. Centimeters standard. If you got the standard length in centimeters, it is 500 centimeters. But you can see small changes. No, small changes. This is a correct one. This is a correct standard one. Only one standard metal rod. Other all are two standard metal rod only. Other all has a variation due to some reasons. Understood? Right. Then calculate the mean of the length, mean of the rod. Calculate the mean of the rod. Okay, you have to calculate the mean of the rod. You have to calculate the mean of the rod. Okay, some parts make a homework due to this cumulative frequency asking, and you will confuse. That's why I told Tony. Yeah, you can work with me. Okay, what's the method you have to use for calculate mean? Which method you can use? Dihini. Simple frequency method or ungroup method? First method or second method? Now we have discussed two methods. We have two methods. First method, ungroup simple frequency distribution method. The second method, ungroup frequency distribution method. Which one is the best? Not best. According to this question, what is the method you have used? No answer. Dihini? According to this question, what is the method we have to use? First one or second one? Anke one, first one or second one or two? Ranga? මතක නැද්ද? මම තමයි අසනීපුනේ. ඔයාලා හිටියා නේ. ප්‍රතිමා? What's the best method to calculate the, yeah, Ranga, let's see. Yeah, you have to consider the pattern of the question. No answer, Udanya? What's the best method? Not the best method, sorry. Best method එක නෙමෙයි අහන්නේ. According to the question, what's the best method? Yeah, you have to use simple method, Ranga, because the ungrouped frequency distribution table asks in the second question. Then for first questions, you can't prepare the table. Then first question එකට prepare කරොත් again you have to get frequency distribution table for second question as well. Understood, Habir? You have to use first our simple method, simple frequency distribution method. Yeah, you have to careful about the pattern of the question. Yeah, that's why if you know these answers, now all methods, all tree analysis method, we doing same thing, but you have to understand which method is best according to the question. Any method you can't use. Fatima, good? Okay, then x bar equal sigma I equal 1 to n xi over n. Dihini, understood? Why we use the first method? What's the reason? You have to understand. The reason. No? Because the ungrouped frequency distribution table asking the second part. You can't prepare the table in for first part. Okay. Okay, what's the summation of all data? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 rows. No? Yeah, 20 data. Only 20. It's not tough. You can calculate. Okay. You can add the summation of all numbers and divide by 2. Then you can get the mean. What's the answer? Can you send me what's the summation of all numbers? Fatima? Don't take time. We don't have time to. I want the sum of all numbers. Dini, I got it. Tanga, 495 plus 498 plus 506 plus 503 plus 10,000 12. 10,012 divided by 20. That's a mean. 10,012 divided by 20. It is 500.6. 500.6 is the mean of the distribution. 500.6 is the mean of the distribution. Others, is it correct? The summation correct? Kabir, is it correct? Yes, correct, right? Yeah, then 500.6 is the mean of the distribution. 500.6 is the mean of the distribution. Right. Then construct an ungrouped frequency distribution for the length of metal rod. This part don't need, that we can discuss later. That we can discuss later. Cumulative frequency I will explain later. Right. How to convert this? Now it is data set, right? Just data set. The question asks, what is a construct as ungrouped frequency distribution? Ungrouped frequency distribution. How to prepare as ungrouped frequency distribution? You have to prepare the table. You can prepare a table like this with tally marks. With tally marks. Just you can prepare a table with tally marks. Okay, that's the data. That's the tally mark. You have to remember the steps. Okay, first data 495. 495. First 498. 1. 506. 1. 503. 1. 504. 504. 500. 501. 504. 500. 501. 502. 597. 98. 98. 501. 2021. 99. 99. 1. Okay, that is a ungrouped frequency distribution table with tally mark. This is not the complete table. This is not the complete table. Okay, now you can convert this table into ungrouped frequency distribution table, exact table. What's the step? You have to, what's the method? You have to prepare a table with the data in ascending order. Data in ascending order. Data xi, the frequency fi. Okay, what's the minimum data? 495, right? 495. බලන්න මං හරිද කියලා. 495 is the minimum data. 495. The frequency 1. The second data 496 don't have 97. Only one. 497 only one. 498 3. 499 2. 500 2. 502. 501 4. 501 4. 502 3. 502 3. 503 only one. 504 only one. 505 only one. Final 5, the maximum 506 only one. Okay, remember? Okay, what is the name of this table? Ungrouped frequency distribution table. Ungrouped frequency distribution table. Do you remember? I mean, am I late? We are discussing 2016 A-level question. Sixteen. Kabir, is it correct? Okay, what's the name of this table? Ungrouped frequency distribution table. Ungrouped frequency distribution table. Ungrouped frequency distribution table. Remember the name. Okay, the second question asks, construct an ungrouped frequency distribution for the length of the metal rod and include the cumulative frequency also in the same table. Okay, still you don't know cumulative frequency, but I will add this. Add කරලා තියන්නම් ඔයාලත් ලියලා තියන්න. If you couldn't understand, don't think about this. Okay, this is a cumulative frequency. In the final part, I will explain there are two types of cumulative frequency: increasing cumulative frequency and decreasing cumulative frequency, and more than cumulative frequency and less than cumulative frequency. Okay, this is a cumulative frequency. Adding 1 plus 1 2, 2 plus 3 5, 5 plus 2 7, 7 plus 2 9, 9 plus 4 13, 13 plus 3 16, 16 plus 1 17, 17 plus 1 18, 18 plus 1 19, 19 plus 1 20. That's a cumulative frequency. Don't think about this. Purpose of cumulative frequency and all the information about cumulative frequency I will explain after group frequency discussions. Okay, that's a question number 2 answer 2016 paper. නිකන් ලියලා තියන්න දැටිනවා. Okay, next you have a job. Calculate the mode and median of the length of the metal rod. Okay, now what is the method you have to use? Simple method or ungrouped method? Ranga. Now what is the method? Calculate the mode and median ask. Ranga. Now what is the best method? Fatima? Yeah, very good, Ranga. Now you all have already constructed table. Now you don't need to use first method. You can use second method. Second method means table method. Using previous table, you can get the mode and median. Okay, how to get mode? How to get the mode? Mode. Mode mean what is the definition of the mode? Most repeating value or most frequent value of the distribution. Most repeating or most frequent value of the distribution. The most frequent value, the 4 is the most frequent value, it is 501. The data 501, not 4 centimeters. You have to mention the unit as well. It's centimeters. If you forget length, sorry, unit, you will lose 1 mark. එක mark එකක් miss වෙනවා. Lost වෙනවා. Therefore, remember the question initially mentioned all measurements are all data in centimeters. Then the mode also centimeter value. 501 centimeter or 50.1 meters. 50.1. No, 5.01 meter. 5.01 meter. Okay. The second part, what's the median? What's the median? What's the median definition? The mid value of the distribution. After you prepare in ascending order, the mid value, the middle value of the distribution we called as median. Okay, how to calculate this median? The equation n plus 1 over 2 equal tooth value. Value n plus 1. What's the value of n plus 1? N plus 1 means 20. 20 plus 1, 21. 21 over 2 mean 10.5th value. 10.5th value, that means the value between 10th value and 11th value. Okay. 2, 5, 7, 9, 10 and 11 both 501. It is 501. 501 centimeter. 501 centimeters. 501 centimeters. 501 centimeters. 501 centimeter. Okay, they are the third question answer for 2016 paper. Third question answer for 2016 paper. Okay, do you have any doubt up to now? I know cumulative frequency you have doubt without make a නැතුව වෙන මොන හරි තියෙනවා දෙකෙනි. Any doubt? Hi. Let's move into next part. In same question asks, what can you conclude? That means what you can explain about the location of the data from these answers. These answers mean more than, you can see special, the median and mode was same value, 501, 501. Now this question asks, conclude about the location, where it is located. Where it is located. Yeah, mode and median locate. Yeah, in center. They located in the center of the distribution. They located in the center of the at the center any method. They located at the center of the distribution. At the center of the distribution. Understood? Both center, median කොහොමත් center එකේ the mode value samely was same middle center. Okay, that's why I told explain about center tendency. Last week we discussed center tendency. Okay, center tendency, we have three measurements. We have three measurements to explain about center tendency. I will explain the last part. Mode, median, and mean. We have three measurements to explain the center tendency, mode, median, and mean. We have three measurements, and according to this graph, what is the median value? Sorry, mean value, mode and median same value. What's the mean value? Mean value was 505, no? The mean value was 505, as I remember. Yeah, no, 500.6. Yeah, 500.6. It is very close to this, between 500 and 501. That's why I told there are three measurements: mode, median, and mean. They are the measurements explain about central tendency. Central tendency කියලා කියනවා. ඒ කියන්නේ මේක කොච්චර ටෙන්ඩන්ස් වෙලාද, කොච්චර attractive ද center එකට කියන. Center. Okay, that we can discuss later. Okay, that's the answer. Complete. It's explained about what they located in the center of the distribution. They located at the center of the distribution. Third question done. Calculate the quartile 1 and quartile 3 for the length of the rod. You can calculate, right? Okay, this is your job. Calculate the Q1 and Q3. That's the answer for fourth question. Okay. How to calculate central tendency? Sorry, how to calculate the quartiles? Quartiles are not central tendency measures. On central tendency measures on the second quartile, median. Second quartile equal to median. Okay, Q1. Q1. How to calculate first quartile? What's the method? 1 over 4 n plus 1. 1 over 4 n plus 1 means 21. 21 over 4. 21 over 4. 5.25. Fifth value. Okay, how to get the 5.2 fifth value? 1, 2, 5. Fifth and sixth values are, this is the fifth value, this is a sixth value. Understood? 498 is a fifth value. 499 2 times. Therefore, 499 is the sixth value. Now, what is the method? First, get the 498 fifth value, 498. 498. Same method I explained in simple frequency distributions. 498 multiplied by, what's the gap? 498 to 499, only one gap. Then 1 multiplied by 0.25. 498.25 centimeters. 498.25 centimeters. Hari, clear nede? Kabir? Okay, after you follow this lesson, අපි කරන විදියට, අපි කරගෙන යන විදියට, according to our process, if you follow A to Z completely this lesson, any past paper, any model paper question you can answer. මම completely කරනවා. මම ටිකක් I'm explaining more than required level little bit. 10% වගේ මම වැඩියෙන් කරනවා because sometimes in exam question asking different questions, little bit standard questions. Now your syllabus is now little bit old, therefore easy questions not coming always. Always advanced questions come. 2026 same as 2025. Yeah, any past paper question you can answer up to this ungrouped frequency distribution. Now you can answer for any past paper questions. Today now what is the time? 9:34. Yeah, before 10 I will start. The 9:45 we can start group frequency distribution. It is very important because after 2016, no any questions from simple or ungrouped frequency distribution. All questions were ungrouped, group frequency distributions. That's very important. 8 times in exam. Similarly, in 2016, second part based on group frequency distribution. They are the groups. They are the groups. අපි හරියට කරමු. A to Z. Very important this lesson. If you know part of lesson, you can't answer for any question. So භාගයට දැනගත්ත භාගයෙන් දන්නේ you can't answer. For this lesson, you should have idea about complete sections, complete what's the meaning of simple frequency distribution, what's the meaning of ungrouped, what's a group, everything. And what are the cumulative frequency, what's the meaning of mode, what's the meaning of mean, what's the meaning of median, quartiles, what's the median, what's the meaning of quartiles and interquartile range. You should have idea. No need remember definitions, but You should have idea what are they. අද මොනවද කියලා ඔයාලා දැනගෙන ඉන්න ඕනේ. හරි. Third quartile. What's third quartile? Can you send me? Third quartile value. Dini? When Taka? Don't have time. Fatima? Ranga? Third quartile. Second, what is the second quartile? Second quartile, we already got it. It is 500 pounds. The second quartile. That's median. Habib? What second quartile value? Yes. Q3 equal 3/4 into 21. 21. Okay, 63/4. 63/4, I think it is 15.75. 15.75 value. $15.676 value. Okay, after this level, 5th, 7th, 9th, 13th, 16th, 16th. This is the sorry, 13th, 15 and 16 both 502. Therefore, no need to calculate. 502 is the answer. Centimeters. Then you have to add centimeters as unit. Centimeters. Okay, let's move on to next one. Done. Calculate the interquartile range of the metal rod. From this calculated value, what can you conclude about the length variation of the metal rod? Okay, by interquartile range. Okay, what is the interquartile range first? IQR. Fatima, what is the interquartile range? 502 in Q3 minus 492. Sorry, 498.25. You have to answer now. අට්ටාව දාන්න නැත්තම් වෙලා යනවා. 3.75, right? This is the interquartile range. Okay, the second question, the same question asking, the second part, it asking from this calculated value, what you can conclude about the length variation of metal rod. Okay, I need answer for all. Answer from all. Hamam done. What you can conclude, I already explained in the previous class. what you can conclude, Kabir, what you can explain about, what you can understand about the length distribution by this interquartile range? Quickly. No, you have to explain about distribution. Panga. Distribution explain කරන්න ඕනේ. Fatima, quickly send me what you can conclude, what you can explain. Time යනවා. Still a bit. Still we are doing last week lesson. Dihini. Yeah. If you got range, what is the range of this distribution? Kabir, any idea? They are exam questions. And I already explained about that. What you can explain, what you can conclude using notable balan pasari. I explained about what is the definition of interquartile range and what we can explain about interquartile range. I already explained. Okay, if you got range, do you remember what's the range? 595 and 505. The range of the distribution 10. Okay, by this range, if you got this 10 range, what you can explain? The entire distribution, spreading. Yes, the entire distribution spreading within 10 centimeter. Yeah, that's the meaning, right? The entire distribution of the rod length spreading within 10 because range 10. Okay, do you remember in the first lesson, in the first day of the statistic, I explained about interquartile range, explain middle 50% range, the gap between middle 50% of the distribution. Now you can explain the interquartile range, explain interquartile range of this distribution, explain about middle 50%. Now you can explain the middle 50% of the distribution. The middle, write down clearly, the middle 50% of the distribution the middle 50% of the distribution spreading within 3.75 right. That's all. If you write this sentence, you have full marks. The middle 50% of the distribution vary or spreading within 3.75. ඒක තමයි change වෙන උඩරින් එක. ඒ අතරේ තමයි තියෙන්නේ. If you got the range, what you can include, what you can explain. දැන් මේ වගේම ඔයාලගේ exam එකේ range එක ගැන ඇහුවොත් what you can explain. The range explain the range value 10, then you can explain range එකත් ඕන තියාගන්න. the entire distribution, frequency distribution spreading within 10 centimeters. Within 10 centimeters. Okay, quickly send me. I got. Oh, do I need to explain again? Understood or not? Okay. Others? That clear or not? Fatima Dihini? Yes. The interquartile range explain what? Middle 50% spreading. Yeah, spread වෙලා තියෙන විදිය. The value. This 3.75 according to this distribution. Okay, then you can explain the middle 50% of the distribution spread within 3.75 centimeters. If the question asks about range, the range conclude the entire distribution spreading within 10 centimeters. That the value depend on the distribution. No? Okay, other questions based on group frequency distribution. Write down the topic in your notebook. Group frequency distribution. Group frequency distribution. Group frequency distribution. Third special topic. Group frequency distribution. Okay. Group frequency distribution. Okay, this is the third main topic of the lesson, analysis part, group frequency distribution. Okay. Now, what is the meaning of grouping and why we need to group data? Okay, I told the simple frequency distribution method always we use for simple distribution. Simple means the number of data less than 20 or 25. I told when increase the number of data more than 20, more than 25, more than 30, it is very difficult to use simple frequency distribution methods. We have to go for group frequency table method. Sorry, ungroup frequency table method. Second part, second step that we completed now. Okay, second method. Okay, now when it is increasing more than this level, more than 40, more than 35, more than 50, more than 100 number of data, it is very difficult to prepare ungroup frequency distribution table as well. At the second method, very difficult to manage ungroup frequency distribution table method. Okay, that one also difficult. Then what to do? Okay, we have another option to prepare data in as a group frequency distribution. Then we can prepare groups, data consider as a group and make a distribution table that we call as group frequency distribution table. That we call as group frequency distribution. Okay, write down the first topic. with star mark. My notes you don't need to remember for your information. Write down. When increase the number of data, when increase the number of data, more than 35 or 40, and increase in the type of data, increase in the type of data, very difficult to use, very difficult to use. Simple frequency distribution method or simple frequency distribution method or ungrouped frequency distribution method for analysis. Very difficult to use. Simple frequency distribution method or ungrouped frequency distribution method for analysis. Same point. එකටම යන්න. But we can prepare data as a groups, we can prepare data as groups. We can prepare data as groups to convert group frequency distributions, to convert group frequency distributions, to convert into group frequency distribution for easy analysis. For easy analysis. Previous methods are difficult, but if we can prepare as a group frequency distribution, it is a type of easy analysis method. For easy analysis. Complete writing. But we can use, but we can prepare group frequency distribution table for easy analysis. For easy analysis. Okay, write down second point. The second point. There are two main types group frequency distribution methods. There are two main types group frequency distribution methods. There are two main types group frequency distribution methods. There are two main types group frequency distribution methods. Write down the first topic. Sorry, first one, not topic. First one, continuous group frequency distribution methods. Continuous group frequency distribution method. The second one, discrete group frequency distribution method. Continuous group frequency distribution method and discrete group frequency distribution method. Discrete group frequency distribution method. Okay, first one, continuous group frequency distribution methods. The second one, discrete group frequency distribution methods. Okay, let's draw this type table, graph, chart. Okay, examples. I will explain. I'll give you note about what is the difference. First, write down short note. Okay, continuous group frequency distribution and discrete group frequency distribution. First, understand the difference. Example. 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 0, 10. 10, no need brackets. Better to add brackets. 0, 10, 10, 20. 20, 30, 30, 40. Okay, that's a continuous group frequency distribution. 40, 50, 50, 60, and continue. Okay, that's a continuous frequency distribution. Write down another example. Only examples, no need notes. 0, 2, 2, 4, 4, 6, 6, 8, and continue. They are the continuous group frequency distribution. Okay, understand the difference between continuous and discrete. Okay, they are the examples for discrete group frequency distribution. Write down as examples. 1, 10, 11, 20, 21, 30, 21, 30, 31, 40, 41, 50, 51, 60. Okay, understand the difference. Understand the difference. Okay, let's take another example. Example 1, 2, comma 3, 4, comma 5, 6, 7, 8, 9, 10. Okay, can anyone say me what is the difference between continuous and discrete group frequency distributions? Before that we called as group. Okay, that's a group. 0 to 10 is a group. I'll explain about that. First, understand difference. What's the main difference between continuous group frequency distribution and discrete group frequency distribution? Fatima, what's the main difference? What's the difference you can identify? Ranga, what's the main difference? Kabir. What's the main difference? Udanya, what's the difference between continuous and discrete. Okay, very good. Very good. In continuous frequency distribution, no gaps. No gaps. But in discrete frequency distributions, they have gap. See, they have one gap between these two groups. One gap. Okay, that's the main difference. In continuous group frequency distributions, there is no gap between groups. There is no gap between groups. That means the first group final value equal to the second group initial value. No any gap. Gap 0, 10 minus 10, 0. I got the difference. But in discrete frequency distributions, first group final value not equal to the second group first value. That means it has 11 minus 10, it has one gap. Understood the difference? I got the difference? Yes or no? Jenny? Okay. Okay, write down the first topic, continuous group frequency distribution. Continuous group frequency distribution in next. Below this chart, write down the first topic, continuous group frequency distribution. First topic, subtopic, continuous group frequency distribution. Continuous group frequency distribution. Okay, write down the first point. Write down. There are no gaps between groups and there are no gaps between groups and there are no gap between groups and any group final value equal to the next group first value. Any group final value equal to the next group first value. Harneet. Okay, write down example. Again, write down another example. 1 to 5. Sorry. 0 to 5. 5 to 10. 10 to 50. Okay, like this. Any value, final value, you can see any group final value equal to the next group first value. Next group first value. Okay, that's the main difference. Therefore, no gap between groups. Okay, write down example and write down the second topic, discrete group frequency distribution. 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 Okay, what's the meaning of discrete? Don't write. What's the meaning of discrete? Understand? What's the meaning of discrete mean? Yeah, they have gap between groups, and it's don't write. It's any group final value not equal to the next group first value. Okay, that's the main characteristic. Okay, write down. Any group final value not equal to the next group first value. Next group first value. Therefore, they have gaps between. Therefore, they have gaps between groups. Therefore, they have gaps between groups. Okay, write down example. Any group first value not equal to the next group first value. Sorry, any group final value not equal to the next group first value. As example, if you got 0, 1 to 5, 1 to 5, comma 6 to 10, comma 11 to 15. That's the nature of discrete frequency distribution, group frequency distribution 16 to 20. Okay, write down example. Write an example. See, they have gap, one gap, one gap. That's the meaning of discrete group frequency distribution. That's the meaning of discrete group frequency distribution. Okay, understood the difference between discrete and continuous frequency distribution, because it is very important to continue our lesson, group frequency distributions. Understood? Send message. Sudanya, Temal. The difference, Fatima, Dihini, up to now, okay. Hurry. Let's move into next part, characteristics of groups. Okay, write down characteristics of topic. Okay, characteristics of groups. Characteristics of groups. Another characteristics, another action. Characteristics of groups. Is more than one mean like this? You're asking like this, right? 1 to, yeah, good question. 1 to 5, then again starting 7 to like this. Gap දෙකක් තියෙන පුළුවන් කියලා දාන්න. More than one. Yeah, it's okay. Sometimes in your exam questions you can, and sometimes there is a shape of discrete group 0.1 to 0.2, 0.3 to 0.4, like this. Then how about the gap? Only 0.1, not 1. The gap can be changed. However, they have gaps. They have gaps. 10 වෙන්නත් පුළුවන්. මෙහෙම වෙන්නත් පුළුවන්. 0 to 10. Again starting 20. 20 to 30. Again another 10 gap. Again starting 40 to 50. Okay, they are discrete. You can see they have gap. At least more than 0 gap එකක් තියෙනවා නම්. If it is gap 0, that we call as continuous. Gap එක 0.1 හරි තියෙනවා නම්. Again, more than 0, if they have gap more than 0, that we call as discrete. Got Ranga? The gap can be any value. Continuous, what is the meaning? They don't have gap. That means the gap between two groups 0. But in discrete mean it has more than 0 gap. That's the difference. Very good question. Okay, characteristic. Next topic, characteristic of group frequency distribution. Characteristics of group frequency distribution. Sorry, characteristic of group. Sorry, characteristic of groups. Characteristics of groups. Okay, first topic, class limits. Class limits. Class limits. Okay, class limit. Class limits mean if you got continuous or discrete any group, like example, example 0 to 10, 10 20, or discrete one, example 1 5, 6 10, 11 15, any type of example. Remember, the first value we called as lower class limit. Okay, they are the class limit. 0 and 10, 10 20. මෙන්න මේවා තමයි මේ values තමයි අපි class limits කියන්නේ. Okay, additionally remember the minimum value of any class that we call as class limits. So lower class limit. Lower class limit. Lower class limits. The maximum value of the class, any group, that we call as මේ වගේ එකට අපි group කියලාත් කියනවා, class කියලාත් කියනවා. හරිද? Group and class. It's a one class. One class. The final value of the group that we call as upper class limit. Upper class limits. Okay, they are the lower class limits. They are the lower class limits. They are the upper class limits. Understood? Discrete or continuous, the minimum value of the distribution we called as lower class limit and maximum value of the group we called as upper class limit. Make up short form එක මෙහෙම කියනවා. LCL, lower class limit. Upper class limit UCL. UCL, upper class limit. Okay, good. Understood? Okay, write down star mark. The definition. Write down. The maximum and minimum values. The maximum and minimum values of any group called as class limits. Class limits. The maximum and minimum values of any group called as class limits. Called as class limits. Called as class limits. The maximum and minimum value of any group called as class limits. Second point, the minimum value of any group called as lower class limit within bracket LCL and the maximum value of any class called as upper class limit UCL. Upper class limit within bracket UCL, and note down this example. Continuous or discrete, both. The minimum value of the group lower class limit, the maximum value of the group upper class limit. Okay, complete and understood? Done? LCL and UCL. Fatima, complete? Okay. Note down the second characteristic. Class boundary. Class boundary. Okay, what's the meaning of this class boundary? It is very important because any calculation we need class boundary, not limits. Okay, what's the meaning of class boundary? Class boundary mean, think example. Try to understand. Definitions don't need. Definitions only you need to know what is the meaning of class boundary. If you have idea, you can do any calculation, any past paper, model paper question, you can practice. Okay, class boundary mean, think example. Our previous example, if it is continuous one, 0, 10, 10, 20. If you got a discrete one, discrete example, 1, 5, 6, 10, 11 to 50. Okay. I have two group frequency distributions. The first one is continuous frequency distribution, and the second one discrete group frequency distribution. Okay, now continuous, the second one is discrete. Okay, what's the meaning of this class boundary? If we can consider two nearby classes, that means two groups, if we can make these classes without any gap. Okay, that's meaning example. Now actually, how about the gap in between these two values, 10 and 10? It is 0. Okay, therefore remember, in continuous group frequency distributions, class limits equal to class boundaries. Limits equal to class boundaries. Equal to class boundaries. What's the reason? They already continuous. Continuous mean they don't have gap between classes. Okay, class boundary mean what? If we can make class limits without any gaps, after prepare class limits without any gaps, we called as class boundaries. Then for continuous, they don't have problem. They already don't have gaps. Therefore, class limits equal to class boundaries. Understood? But the problem in discrete group frequency distribution, they have gaps between groups, classes. Okay, then we have to modify only for discrete frequency distributions, we have to modify these class limits to prepare class boundaries. Okay, they are the class limit, lower class limit, upper class limit, lower class limit, upper, lower, upper. They are class limits. Okay, class limits and class boundaries difference. Understand how to produce? Okay. How about the gap 1? Gap 1. Okay, understand. If it is discrete group frequency distribution, we have to get first the gap between classes. Okay, it is only 1. Okay, now you can divide this 1, the gap value, divide into 2, it is 0.5. 0.5 subtract from the lower boundary. Sorry, 0.5 subtract from the lower class limit. 1 minus 0.5, it is 0.5. Understood? 0.5. 0.5 add to the upper class limit. 5.5. 5.5. 5.5. Comma. 6. 0.5 subtract from the 6. 5.5. 0.5 add to the upper class limit. 10.5. comma 0.5 subtract from lower class limit 10.5, 0.5 add to the upper class limit 15.5. I got understood. They are the class limits. They are the class limits modification, class limits modified. Then I got they are the class boundaries. They are the class boundary. And we call these values, these upper values, they we called as upper class limit, sorry, upper class boundaries, UCB. Upper values, the final values we called as upper class boundaries. They are the lower values we called as lower class boundaries. Understood? Lower class boundaries. For continuous group frequency distribution, no any issue. Continuous class limits equal to class boundaries. Upper class boundary equal to upper class limits. Lower class limit equal to lower class boundary. Understood? Yeah, that's the most important part of the group frequency distribution. How to convert discrete group frequency distribution into class boundaries. Send message. Quickly. Do I need to explain again? Dihini, understood? Fatima? Yes, Tanga. Not always 0.5. That depends on the gap. If it is 5 gap, you have to get you have to use 2.5 subtract and 2.5 add. Then 10 gap එකක් આવොත් 5 subtract and 5 add. Always gap එක තියෙනවනේ. Gap between two classes divide by 2. තමයි ගන්න ඕනේ. Okay? හරි. Okay, write down first point. Class limits of any group frequency distribution, class limits of any group frequency distribution if prepare as without any gap between classes, they called as class boundaries. Class limit without any gap, they called as class boundaries. Remember that. Called as class boundaries. Second point, oh, I have to write again. Okay, right. Second point. For continuous frequency distributions, class limits and class boundaries are equal. Class limits and class boundaries are equal because they don't have gap between class limits. Because they don't have gap between class limits. Because they don't have gap between class limits. Class limits and class boundary same. Write down example. Example. Class limits equal to class boundary. Okay, they are the upper class limit. Upper class limits equal to upper class boundary. They are the upper class limit and upper class boundaries. Upper class limit equal to upper class boundaries. Lower class limit equal to lower class boundaries. LCB. Okay, write down like this. Okay, next point. For discrete group frequency distributions, class limits and class boundaries not equal. Class limits and class boundaries are not equal. Class limits and class boundaries are not equal. Therefore, we have to prepare class boundaries separately. We have to prepare class boundaries separately. We have to prepare class boundaries separately. Okay, example. I got only 3 classes. Okay, how to prepare class boundaries without any gap? We have to prepare without any gap between classes. Okay, how to prepare? Okay, what is the gap between two classes? It is 1. Then 1 divided by 2, it is 0 0.5. 0 0.5 add to the, subtract to the lower class limit. 0 0.5 subtract to the lower class limit and add to the upper class limit. Please note down like this. Okay, then you can prepare 0.5, 5.5, 5.5, 10.5, 10.5, 15.5. Okay, note down. Okay, they are the lower class boundary now. They are not limits, they are not class, they are class boundaries, they are the upper class boundaries. Upper class boundaries. Okay, note down like. Okay, complete. Complete. Tanga. Okay, completed. Fatima. Okay, that's the meaning of class boundary. Class limits complete, class boundary complete. Write down the next topic, next subtopic, next characteristic. Characteristic number 3, class size. Class size. Class size. Class size. Class size. Okay, what's the meaning of class size? What's the meaning of class size? It's simple. The maximum number of data, maximum different number of data can have in a class and include in a class. Okay, as example, If you got a continuous one, let's get same example, same as previous. 0, 10, comma 10, 20, comma 20, 30. Same example I got for you understand. After that, we can get and the examples and calculate. Okay, class size means the maximum different number of data that can have in a any class, in a one class. Okay, if you got first class, 0 to 10 class. Okay, what do you think? What is a class size? What is the maximum different number of data that can have? Okay, remember for class size, we have equation, the class size equal upper class boundary, that is a condition, upper class boundary minus lower class boundary. You can't use class limits, that's restrict. Okay, always you can use class boundary, but fortunately in continuous frequency distributions, class boundary and class limit same. Okay, how to get class size? For first class, upper class boundary 10, lower class boundary 0. Then what the class size? 0, 10, 10, sorry. For second class, 20 minus 10, 10. For third class, 10. Okay, this is the group frequency, continuous group frequency distribution with class size 10. 10. Class size 10. Let's get another example. Another example. Okay. Now it is a discrete group frequency distribution. How about the class size of first class? 5 minus 1, it is 4. 10 minus 6, it is 4. 15 minus 11, it is 4. Am I correct? Am I correct? Yes or no? Kabir? No, completely wrong. Completely wrong. Okay, that's the mistake you doing always. Har de wala dekka gaman tattakal class size fill karගෙන යනවා. Next time, lot of this is a mistake you doing in group frequency distributions. Okay, it is not actually 4. බලන්න වෙනස් වෙන විදිය. Okay, if you can convert into class boundary, they are class limits, no? Okay, you have to convert class boundary. For discrete group frequency distribution, it is 0.5 minus 0.1 to 5.5. 5.1, comma 5.5 to 10.5. 10.5 to 15.5. Okay, now what is that? Now correct. Now class boundaries. Class boundaries 5.5 minus 0.5, it is 5. Alin kiyada 4. It is wrong. Wrong, okay? 5. 5. Clear? Okay, write down the first point. The maximum number of different data, possible to include in a one class, called as the class size. Called as the class size. Okay, write down below. Class size equal expression. Class size equal upper class boundary minus lower class boundary. upper class boundary minus lower class boundary. You can't use class limits. Write down examples. A bit. Ranga. Hi. Okay, now what we discussed up now, we discussed about class limits, class boundaries. Now we completed class size. Okay, write down the final, not final, next characteristic, fourth one. Fourth characteristics of groups. Fourth characteristics of groups. Class mark. Class mark. Class mark. Okay, what's the meaning of this class mark? Now the class mark here, the marks of the students in the class? No, no. What's the meaning of class mark? Remember, the class mark is the midpoint of any class. That means midpoint value of any class. That we called as class mark. Actually, the median of the class came up. The median, the mid value, the center value of any class. Okay, how we calculate this class mark? class mark equal upper class boundary. Okay, always remember to use boundaries. Limits kattat meka nangena, but better to get boundaries. Upper class boundary plus lower class boundary divide by 2. Simple. Upper class boundary plus lower class boundary divide by 2. That's a class mark equation. Okay. Then how to calculate class mark? For example, previous example, 1, 0 to 10. $20 to $30. Okay, how to calculate class mark for this continuous one? How to calculate upper class boundary equal to class limits, no? Then upper class boundary 10 plus 0 divided by 2. The class mark 5. 5 is the class mark. 5 means the mid value of any class. Okay, 10 plus 1, 20. 20 over 2, it is 15. 25. Okay, that's a class mark. Okay, let's get another one, discrete one. 1 to 5, 6 to 10, 11 to 15. Okay, what's the class mark? 5 plus 1, it is 6. 6 divided by 3. Is it correct? 5 plus 1, 6. Sorry, 5 plus 1, 6. 6 divided by 3. 3, correct? Kabir, what do you think? Is it correct? Then 6 plus 10, 16. 16 over 2, 8. Eleven plus 15, 11 plus 15, 26. 26 over 2, 13. 30. Are they correct? Dihini? 3, 8, 13. Are they correct? No, correct. They are correct. Why? Remember, if you got class mark using boundaries and using limit, same answer. Remember, if you got boundaries for this, but remember this equation. That's a boundaries for class size. Definitely, you have to use boundaries. For class mark, you can use boundaries or limits. Both. See, 0.5, 5.5. No? Then what is the sum value? 0.5, 5.5, and it is 6. 6 over 2 again. Same. But better to remember class boundaries, but class limits are no class mark. No issue. Okay, write down. The mid value of any class. The mid value of any class called as a class mark. Okay, write down class mark equation. Upper class boundary plus lower class boundary divided by 2. upper class boundary plus lower class boundary divide by 2. Upper class boundary plus lower class boundary divide by 2. Upper class boundary plus lower class boundary divide by 2. Okay, and write down these examples. Write down examples. Okay, complete. Okay. Okay, that's the end of theory part of this lesson. After that, we have calculations. Okay, complete. Yes, write down the topic. Development of group frequency distributions. Development of group frequency distributions. Develop the development of group frequency distributions. The development of group frequency distributions. Okay. Can we continue today 12 up to 12? I'll give you interval now. 10 minutes. And let's complete this part. Then next week, we can complete the analysis part and start interpreting. Are you okay? Okay, now 11. I'll give you 10-minute break. After 10-minute break, I'm starting 11:10. The development of group frequency distribution is an important part. Okay, take a break and
come again 11:10.
Okay. Hello. Tell me, Violet. Okay. Tell me, you have to watch the recording. Okay. Now we are doing development of group frequency distribution. Without our previous part, you can't understand this. Okay. However, you can. If you want, you can go to our YouTube. Go to our YouTube channel and start beginning. නැත්තම් පස්සේ හරි බලන්න. Okay. Okay. Okay, development of group frequency distributions. Now you know everything about what's the meaning of group frequency distributions and what are the types of group frequency distributions, what are the types, continuous group frequency distributions and discrete group frequency distributions. Continuous mean no gap between classes. Discrete mean there is gap between classes. And we discuss characteristics, what's the meaning of class limits, what are the class limit of discrete and continuous both, what are the class boundaries of discrete and continuous both, what are the class limits, what are the class size of discrete and continuous both, what are the class sizes and class marks of group frequency distributions, both continuous and discrete frequency distributions. Hari. Now we are going to how to develop data set as a group frequency distribution. Hi. Let's write down the frequency first. Give me 1 second. Okay, write down with me. Quickly write down. Question number 1, exercise number 1. 13, 6, 15, 20, 24. Clearly write down. 37, 44, 51, 54. $60. $10, 15, 21, 32, 43, 55, 25, 4, 13, sorry, 14, 13, 3. 14, 13, 3. Zero 9 mean 9, no? 9. බිඳුවයි 3 කියන්නේ 3. 57 final. 57. 57. Okay, write down the question. Are you complete? Are you complete? Complete. Okay, write down using above data set. Using above raw data set. Raw data set. Develop a continuous group frequency distribution. Frequency distribution. FD means frequency distribution with 6 classes. 6 classes. This is a question. I have raw data set. I want to this raw data set convert into, highlight this word, continuous group frequency distribution with 6 classes. Continuous group frequency distribution with 6 classes. Number of classes 6. 6 classes. Continuous group frequency distribution with 6 classes. 6 classes. Okay, complete. Hari, api hadam. Complete writing. Send me message all. Fatima. Okay, now I want to develop continuous frequency distribution. Continuous group frequency distribution with how many classes? 6 classes. Number of classes 6. Hari, me bala. First of all, I can draw a table. I can draw a table. First of all, I can draw a table. This is a class or group. අපි දාමු මෙතන class limits කියලා. Class limits. Class limits. Class limits. This is a tally mark. Tally mark and frequency. Frequency. F5. Class limits, tally marks and frequency. Class limits, tally marks and frequency. First of all, what is my requirement? First of all, I need to know, I know it's starting from what is the minimum value? Can you send me what is the minimum value of this distribution? What's the minimum value of this distribution? What's the minimum value of this distribution? Ranga. What's the minimum value of this distribution? Three, very good. 3 is the minimum value. Hari, okay, then so my distribution is starting from 3. Group frequency distribution is starting from 3. Next, I don't know what's the meaning of class size. Class. Okay, therefore, you have to find the class size first. Class size. Class size. Okay, what is the class size equation? Fatima. What's the class size equation? Previous session I explained. It's a class size equation. Class size equation. Abi? Yeah, upper class boundary minus lower class boundary. Yeah, this is the equation. Upper class boundary minus lower class boundary. But do you know upper class boundary or lower class boundary? No, you don't know. Therefore, you have to use another method to find the class size. Remember, this is a method. First, you can find the range of this distribution, right? If you don't know upper class boundary or lower class boundary, you can use second optional method to calculate the range, class size. Class size. Range you can divide by number of classes. Number of classes. Number of classes. Range you can divide by number of classes. This is the class size. This is the class size. And you have to careful, I will explain. Okay, now range. The minimum value I got 3. Then what is the maximum value? Can anyone send me maximum value of this? Maximum value, maximum value. Maximum. What's the maximum value? 60, 62. Where it is located? It's 33. Okay, not 83. 33. 62 කොහෙද තියෙන්නේ? Yeah, 60 තියෙනවා. After that yes, 62. 62. These are maximum value. Then 62 minus 3. This is a range. Range divided by what? Number of classes. In the question given number of classes 6. Number of classes 6. 62 minus 3, it is 59. 59 divided by 3, what is the value? 59 divided by 3. 59 divided by 3. Sorry, 6. 59 divided by 6. 59 divided by 6. .8. 9.8 is the value. Remember, if you got any value, method 9.1 hours, 9 or 9.1, 9.8, 9.9 hours, kiyada අපි ගන්න ඕනේ? 10, remember. 10 තමයි ගන්න ඕනේ. Next value always get the next nearest whole number. Next value, not round off. හැම වෙලාවෙම ගන්න next එක. Next full number, whole number. Understood? Get next whole number. Rango okay? It's 10. Understood? Now my class size 10. My class size 10. Alright. Then 3, it is a continuous one. Therefore, I add 13. And I can check the class size. 13 minus 3 are correct. It is 10. It is continuous. Therefore, starting from 13 again. 13 plus 10, 23. 23 again, starting 23, 33. 33, 43. 43, 53. So 53. 53, 63, 1, 2, 3, 4, 5, 6. 6 classes complete. And what is the final data? Maximum 62. I got up to 63 with no issue. It's a no issue. Now table completed. Table completed. Next. Next we have to add the tally mark. First take under. First 13, 6, 15. I have issue now. Now there are two 13s. Now first value 13. First value 13. Now there are Two 13s. Two 13s. What to do? Two 13s. Where we add tally marks, first one or second one? Okay, what do you think? What do you think? Any idea? First or second? That I need. Okay, remember the meaning of first class starting from 3 to up to 30, up to 13. Therefore, always 13 is relevant to next one. Starting from 13 up to 23. Then this is the first one. Remember, always we add to second one. 615. 6 into first one, 6, 15, 15 into second one. 20, 24, 36. 36. 37. No issue. 40, 51, 54. 40, 51, 54. 60, 10, 50. 50. 21, 32, 43. 21, 32, 43. 21, 32, 43. 43, where you add into second one, 43. Hurry. Next one. 51, 25, 40. 51, 25, 40. 13, 3, 28. 13, 3, 28. 18, 31, 43. 18, 31, 43. 18, 31, 43. 43 into next one. 50, 62, 44. 50, 62, 44. 50, 50, 62, 44. 62, 44. 21, 79. 21, 79. Final row. 56, 16, 3. 56, 16, 3. 56, 16, 3. 6, 19, 40. 6, 19, 40. 6, 19, 14. Final 4 digit. 5, 20, 33. 5, 20, 33. 5, 20, 33 into second one. 33 දෙකක් තියෙනවා යට එකයි එන්න ඕනේ. Final value 57. 57 into final one. Okay. Understood? වැඩි තේරුණාද? Fatima? Okay, understood. And complete. Ranga? Fatima? Complete? Har. Sabir? Understood and complete? Okay, next step, final step, you can fill the frequency column. 8, 12, 5, 3, 6, and 5. Next, you can add these numbers, and if it is coming 40, it's correct. You correct. But 20, 20 plus 5, 25, 25, 20, 25, 30. I have missed one value. I have missed one value. Voila. Could you find any value? 8. This is a mistake. Curie. Sorry. It is මෙතන මම 1 2 3 4 5 6ක් දාලා තියෙනවනේ. Then it is 6. Yes, yes, yes. Should be 30. 1, 2, 3, 4, fifth one, then adding 30. Now correct. Now it is 40. Sigma equal 40. Okay, what is this? This is the group frequency distribution, continuous group frequency distribution. Continuous group frequency distribution. Hurry. Complete, everyone? Hurry. Then let's move into final question for today. Develop same distribution. Sorry, develop same raw data set. Same raw data set. Same raw data set, RAW, raw data set as discrete group frequency distribution discrete group frequency distribution with 5 groups. Discrete group frequency distribution with 5 groups. Hari. This is the question now. Okay, what is your first step? Calculate the class size. How to calculate class size? Class size. What's the equation? Range over number of classes. Range over number of classes. How about the value of range? 59. Previously I got. Number of classes 5. 59 over 5. What is the answer? 59 over 5. Quickly send me. $59 over 5. $59 over 5. Why I got 5? Because number of classes 5. 59 over 5. 11.8. Then you have to get next whole number 12. 11.8 is the answer, but you have to get 12 is the class size. 12 is the class size. 12 is the class size. Hari? Okay, next I got the class size then I can prepare the table. Very simple. Very simple. What's the first column? Class limits. Class limits. Tally marks. And frequency Fi. Frequency. Hurry. Start working. Starting from tree. Starting from tree. Class size 12. 3 plus 12, 15. Am I correct? Then it is a discrete, no? Therefore, I add 16. 16. And class limit 16 plus 12, 28. Am I correct? Ranga, what do you think? Am I correct or wrong? Harida Varadi. Fatima, what do you think? Am I correct? Dihini, am I correct? Dihini, correct or wrong? What do you think? Correct. No, some send me wrong. Salmia, what do you think? Kabir, correct or wrong? Correct. No, I'm wrong. What's the reason? In previous one, no problem because it is continuous. It's continuous, therefore it's correct. But this is completely wrong. What's the reason? Ranga, send me wrong. What's the reason? Ranga, what's the reason? Yeah, you correct, wrong, it is wrong. What's the reason? If you got class boundaries for this class 2.2, it's 2.2. So 2.5, sorry, 2.5 and 15.5. 2.5 and 15.5. Okay, how about the actual class size of this one class? At the class size, 15.5 minus 2.5. It's 13. But our requirement only 12. Dihini, understood? Then I am wrong. Therefore, I have to change it. Therefore, when you prepare discrete frequency, group frequency distributions, you have to be more careful about class sizes. Okay, that's why I told you in continuous groups frequency distributions, class limits equal to class boundaries. Therefore, no worries. But discrete, you have to be careful. You have to be more careful. Okay, I'm starting from tree. It's okay because minimum tree, and I have to add 15 here. 15 I have to check it again. 15, then class boundary 2.5 and 15.5, then class size becomes 13. Then 15 I can't use. Then I'm going to add 14 here. 14 is 14.5 minus 2.5. It's coming 12. Then මෙතනට අපි දාමු 15 because one gap, within one gap. Then 15, if you add 27, you are wrong. We have to add 26. අපි මෙතන gap එක ගත්තා නම් හරි. What's the gap? Actual gap 11. Then you can add values with 11 gap. 15, 26, 27, 38. 11 gap. But class size 12. Class size 12. 39. 50. 51. 62. What's the maximum value? 62, right? Then no issue. No issue. I got only 5 groups, 5 classes. But they want Ranga. Fatima. Abir. Now easy. Now same method at tally marks. Tally marks දාගෙන යන්න තියෙන්නේ. 13, 650. 13 into first one now. 6, 15 into second one. Can you complete this? 20, 24, 37. 20, 24, 37. Can you complete this and complete your table and write down your homework? Write down your homework. Write down your homework. Complete this table. It was tally marks ගන්න මේ පැත්ත දාන්න තියෙනවා. Okay, write down your homework. First part. Keep 1, 2, 3, 4, 5, 6 rules above. මෙතන empty space එකක් තියෙනවා. And develop. Write down first part. Develop as continuous group frequency distribution with 8 classes. Wait, 8 classes. No, 18, 2.5 and 14.5 is not class limit. Ranga. They are class boundaries. එතකොට අපිට class boundary එකේ දාන්න බෑ class limits. Sorry, class limit එකේ දාන්න බෑ class boundaries. We have to add class limits. අපිට නම් මෙහෙම කරන්න පුළුවන්. මෙතනින් we can get another column, write down class boundary and add class boundary. It is class limit ne topic. Okay. Yes. Yeah, good question. Like this, if you have any doubt, you can ask. Develop as continuous group frequency distribution with 8 classes. 8 classes. Second one, develop as discrete group frequency distribution with 7 classes. Okay, that's your homework. The data set I will send into group. මෙතන space එකක් තියාගන්න. I will send into photograph into group. Then you can write down and calculate and practice your maximum And next week I'll discuss how to the further analysis. Today I discussed only development analysis, not discussed how to calculate mean, how to calculate median, how to calculate range, how to calculate interquartile range, and finally interpreting data. Apita adas dekaki make iwara ganna puluwan statistics. Within 2 weeks we can complete. Okay, any doubt today lesson? We did very important thing, important part actually. Any doubt, Ranga? Everything okay now? Yeah, I know still you not familiar this class limits, class boundaries, class size, class mark. It's familiar name on that. If you familiar these terms, the very important thing this week you have to go through this theory note. Theory you have to familiar class limits කිව්ව ගමන් එන්නට මොනවද මේ කියලා. හරි definitions don't need. Class limits කියන වචනේ දැක්ක ගමන් මොනවද ඒ කියලා එනවා නම් ඇති. හරිද class mark කියන එක දැක්ක ගමන් ඒ මොකක්ද කියලා ආවනම් that enough. No need definitions. හරි class size කිව්වම class mark එක ඒක misunderstand or change වුණොත් හරිද වැරදියට තේරුම් ගත්තොත් the entire problem the question will be wrong. 10 marks plus වෙන්න පුළුවන්. හරිද? ඒක නිසා ඒ ටික familiar කරගන්න ඕනේ ඉස්සෙල්ලා. What's the class size, class mark, class boundary, class limits? Yeah, that's the first task in this week. Okay, next one, I will send you a data set you can prepare as group frequency distributions, continuous and discrete both. Okay. Okay, let's meet next week.